Welcome to the free tutorial TV once again, and today we are going to talk about a NumPy universal function. In the short, we call it a U function. And in this U function, what is U function? U function is nothing but it is a universal function where you will be operating on an ND array objects, and you have each of universal functions like related to mathematical functions and many more are there. So what are the universal functions we'll be going through a zip function. Zip function is nothing but it is joining the both an array into a single array. It is much similar to concatenate or maybe join, but here it is one to one zipping. So like say it's more about no selecting from that a particular index similar to another index. So it is not going to join like say the end of the array and then join the next array, not like that. It is joining index to index. So you to run a zip file you can use a for loop, and still you can generate this. So let's see that how a zip functions work in a pie chart. So let's implement this. Let me comment the earlier code. Okay, and any other way to okay, this also needs to be commented. Now here we are going to generate a zip function array. So we will be having a two array called xy and another empty array called z. So for I and j in the zip, that will be running between the for I in the x and j in the y, and then we are appending the I plus j for the addition of the index of I and index value of j and appending into z. And this is the output we are going to see here. So let's say that x equal to, I'm having an array, say 1 2 3 4, and then another array called y. So I'm having y here 4 5 6 7. Okay, and then I will be generating another z which is an empty, and use a for loop for I comma j in zip function, and within these functions I'll be writing x comma y, and then you are going to append in z, you append z with I plus j, and then after appending what I'm going to do is print z. Okay, so let me run this code and let's see that. I need to have one colon here and then run it once again. See here, so the first is 5, that is 1 plus 4 is 5. The next one becomes 5 plus 2 7, and the next one become 9, the next one become 11. And this is how the zip functions work in the normal distributions. Now let's see, there are many other functions where you can directly use add functions, and you can also still get by using that above code. So what is the time? We'll just see that. Now if I use add, then we can just print, okay, here np dot add. So in this x comma y, it also will add same thing, but it will be very fast. So using zip and then for loop, it takes more time consuming and compared to using the add module. So there are many other universal functions where you can use from py function, and from py functions you can add however you want with giving indexes and then you can also use by defining a separate function called definition of a function, and you can call this function using from py function, and you can call myadd as a function into the py function parameter, passing with a value called 2 and a 1, and you will be able to get myadd. And in this myadd you can supply your variable array 1 and array 2, and that's how you will be able to get the result. The same way you can also do the add command and still you get the output. So just going through the universal functions and those simple arithmetic functions available in NumPy. You can use subtract, and also still it will work for subtraction of two array 1 and array 2, multiply, divide, power, and remainder using it mode, and then division mode and absolute. These are some functions which are used like truncation, fix, rounding, floor, seal. These are all can be used in NumPy. And then you can use truncations or fix, and you just run this code and see what's the difference between a truncation and fix. You will be able to understand that. And you can see round. How can you round up this value to the nearest highest value? If it is 3.1, it will be obviously comes to 3, and if it is something like say 3.5, then it goes to the higher value to round up. So you want to see that's how the round work. Let me comment this. Now if I see here, the example has been given with an array of particular float value. So what I'll do is say I'll just generate x equal to np dot array, say array 3.16 comma 2, and then what I will do is you want to use print. I will print directly np dot here I'm going to use round. So if I say round of x, then what exactly the output will be? I will give directly here, and then directly we'll print x, and then we'll see how the output does. Okay, 3.16. If it is say, if I give 5, 6, 7, something like this, what is the output? You just see here it was 3.17, because this number is going to that. And if I change this one to say 3, what exactly happened? Output, so 3166. It is rounding off to that particular digits, whichever you want. So this is about rounding. You can see floor, and you can see ceiling, and you can see log generation. See, log is also available as a functions to the NumPy. You can do log calculation, and you can always do from py function, and you can always use log as one of the function and call it for fish base you want to execute. You can always use array, and then you can do summation. Addition and summation is same, but still it does the same work, but a different functionality is there. And then it will give you can also do cumulative summation, and you can also do product is also one, and multiply is also one. So there are different ways of doing the multiplication factors of array. And then you want to do the multiplication factors by giving in an axis 1 or axis 2, you can do that. And the cumulative product is also can be done by using this cum product prod, and then you can use to find LCM of a number. You can find a HCF of a number, Okay, and you can find a h shape of a number, gcd of a number. Okay, and then you can also find the trigonometric functions like say sine, pi, everything. Let's do this example where sine, you can use np and the sine, and then you give uh, a pi. So here I'll just comment x, and then here you see this x equal to np dot sine of say pi by 2. What is the output? Let's see that. Okay, pi is not defined. To define pi, I think I need to include math or something like that. So let me go and see that how it's given here. It's giving here np dot pi, so it will be using this pi from the you want to use that from the numpy pi. So I'll use here, and then it's generating 1. So sine of pi by 2, then we'll say sine pi by 3. What happened to pi by 3? This is the value, and you are having a problem here. Then you see here np dot round, then I will use this quote round comma, I say 2-digit round up, and then if I run this, what happened? So it runs only 0.87. Perfect. Now if I change this one to 5-digit, what happened? Yes, it gives 5-digit of sine value. You can generate cos theta, sine theta, tan theta, anything for degree. Again, degree to radian to degree conversion. You can always do that, and it will be returning into an array only. So imagine that you are giving an array of this size, and then and when you run this degree to radian of this particular array, it will be always returning as an array. Same radian to degree, you can go through that, and you can go for arc sine, arc tan, no, that one you can go to that, and you can also run this code and just run. And this is hypotenuse. If you know the base perpendicular, you can always find out hypotenuse. Okay, so this is one example of using so we'll do this example just to how it works. Let's find out. Now say if I have a base value of say 10, and I have, what is that, another perpendicular, so pp value as 25, then let me find out the hypotenuse. So hypotenuse, I put x equal to np dot hypo hypot hypot, and then we give here base b comma pp, and then you just run. See that this is hypotenuse. The hypotenuse value is 26.9 something. So this is how you calculate the hypotenuse. Then you can calculate the cosine value, and then the sine and tan you can find out, and then you can do a set operation. So what is a set operation? So in using in mathematics, so a collection of unique elements are sets. So you can also do the operation in set. You can create a set in numpy, and you can do operation. So set is nothing but it's a unique it is a unique number generation. So you can always have a unique array in the sense this array where the repetitions are happening, it will remove and it will generate as unique array. No repetitions will be there, so it is a set. So how you create a set? Then you can have an intersection. You can do a set difference in one dimension. Then you can go for set or in the one dimension. You can also go for all these set operation, union operations, difference operations, set or operation. You can always do all these operations in numpy very easily. So with this, I'm ending off the classes on the uses of NumPy library in Python, and it is very useful for AI applications as well as data science. And if you know all these keywords used in the NumPy library, it will be very much helpful. So why I'm doing this basics course right now is the next course I'm going to into the designing of AI applications. So guys, stay tuned into my channel. The next course will be coming up on designing applications using AI. Thank you. Bye bye. Have a nice time.